there's a really interesting experiment going on in Italy that's been
Hello,
trying to
wonderful person.
discover the mysterious dark matter for a few years now. And last
I
year we
think we caught a
discussed one
couple
of the
today.
major
I did
announcements from
pretty
this
good.
experiment that
It's stuff about
potentially
dark matter. It's like
identified
old
something
schoolers like, oh,
unexplainable. But a very recent analysis and a very recent paper reanalyzing a lot of this data discovered something a little bit more interesting,
well,
a little
I
bit
get
more
there about
intriguing,
the feeds
and
and feeds on the
potentially a
dials
little
that they're
bit more
doing, and if they're not
groundbreaking.
using
Hello, wonderful
Lagrange
person, this
scans,
is Anton,
oh, they're
and today we're
racist.
going to be discussing this particular study that suggests we might have actually discovered dark energy. The concept that we kind of know
And then
even
there's
less
like the
about.
Dubai or
So let's discuss this
the
in more
tens, the
detail
nines, the
and talk
eights. That
about
was a
some
cool
of
little
the
set. And
potential
then guy
discoveries
turns over.
coming out
Maybe
of this
the
study.
expert plays in because you
First of
want them all
quick
messed up on the
reminder,
first day.
and I
That's
guess
dark
quick
matter particle.
clarification.
I got to
Dark
figure out which
matter,
one they're
despite
doing.
its somewhat unusual name,
How the
does not
mill
necessarily mean that it's some sort
actually
of particle.
makes
It's
all
more of a
that thing
phenomenon,
do.
an unexplained phenomenon that seems to cause a lot of matter in the universe to sort of stick together a little bit more and to cause certain increases in mass where there should be none. We've discussed this idea a lot before, and I've also discussed a lot of the proofs behind this, but at the moment,
They
nobody
are vector
really knows what's
positions.
causing all
Now,
of these effects.
can you
And so
imagine
in
putting them
reality,
all
instead
on one
of
piece of paper
calling
and be
it
like,
dark
oh,
matter,
you're right,
we
it'd be
should be
this
calling
thick. So
it
let's put a
some sort
couple
of a
of points.
gravitational
We don't
anomaly,
necessarily
or
need
some
to
sort of a mass
one
anomaly.
point
It
on
does
the
not
thing and look
necessarily
at
mean
it and
it's
see
made out
at
of
some angle
particles,
that it
but one of
could be
the
rock
most
shell.
leading theories,
I mean,
and I guess some of the best
a battery in
explanations
your
in regards
car,
to dark
it
matter,
does
do
all the
propose that
entropy.
it
It's
might
just
contain
in the
some sort of
compression
particle.
of the motor to
Specifically,
hot to
there are
cold.
two major theories. Either
Expansion 0 to 1.
particles known as WIMPs,
Board
weakly
phase, you
interacting
gotta do a
massive particles,
review,
or
or
another
on
concept known as
just
axions,
figuring out
both of which
particles that
theoretically make sense,
just a whole,
but neither
it's an
one of
issue.
which has
It in
so
itself
far
is
been
a
detected.
type of issue
Although
where
interestingly enough, last
it's
year we
thick.
discussed this
Like,
unusual detection
it's
from
tough.
the experiment known as Xenon 1T. The experiment you can learn more about from one of the links in the description. In a nutshell, just like some of the previous experiments with a similar name, most of these experiments usually involve some sort of a really large tank filled with liquid xenon.
Okay, this
With
one looks
xenon
like
being that noble gas that doesn't really react with much and generally does not produce a lot of emissions. And so if something
well,
passes
there's your
through this
test.
gas,
I mean,
and
it's like, how do you
specifically
get
here
your
we're
droid to
talking
do
about some
this?
sort
And
of
then the
dark matter
output on that
particle,
thing looks like
in
this.
theory,
And then
it should create some sort of an emission.
you're
And
playing
so a lot of these tanks will also often contain some of the
quantum
most
physics
advanced
Jeopardy
sensors
with
in the
Sheldon
world. Here's actually the
and
image
Leonard
from
and
this particular
Taj
experiment, with each of these sensors
the other
being
guy,
able to quite
Larry.
accurately
Yeah.
detect and position every single particle that interacts with that particular tank of xenon. And to make sure that there's an actual detection and that it's not some sort of an error, normally the scientists first run the experiment by trying to measure the background radiation,
Plays in the
and then
simulator.
use
They
these
like you when
measurements
you do
as a
it
kind of
because
a
it's one,
baseline
both
in order
interesting
to detect
and
any
useful.
potential extra particles then hitting the tank. And so it just so happens that the data released from last year, with the data itself
I
representing the
don't do it
collection
for
for
the, I do it
approximately
for
2
the big
years
hat. It
between
wouldn't matter who comes
2016
in.
and
You see the
2018,
marshmallow on the thing that we
detected
do for the
53
quantum
X-ray
physicist
events
stuff that
on
it
top of
does.
the
Yeah, well, there you go.
232 background radiation events that were
There's a
expected
bunch
from
of them
this
out
particular
there.
experiment,
Like, there is
which presented
loggers
a lot
and
of
there
interesting
is stone
opportunities to
masons
study
and a
and to
bunch
try to
of
figure out
mathematicians
what
and
exactly it is that the
bankers.
scientists have discovered. But in order to analyze the actual interaction of particles with the tank of xenon, the scientists had to rely on the mathematical models, mostly because, well, the only data they have from all of these detections is the amount of energy that's being produced by every single particle interacting with xenon. And so if
And it
the
doesn't
mathematical
exist
model for
until
example,
you
dark
could be
matter
like,
axions
okay,
matches the
in
observations,
general,
in this
you
case, it
know,
would mean
I'm
that
to
we
advise
finally
the
detected dark
president. What
matter.
that means is I'm good
But
on board. I
unfortunately,
can make
the
a
original
presentation by
predictions
putting
or
that
the
out there,
original
by
analysis
headings on
determined that it's
situations
very,
that
very unlikely
parallel,
for these
and give you
particular
some
particles,
limits inside of
these
there
53
of
X-ray
A or
detections,
B,
to be
and then they all
axions, or to
marshmallow
be any
because
kind
it
of a
doesn't
dark
matter
matter
which ones
particle
the
that we
those are,
originally
it's just the
predicted.
schematic that you
Mostly
do.
because, well,
And
there were
so,
just too many.
vector position,
We would
be little
require
black
a lot more
black
of these
dots on a
axions
5 by
everywhere in
8
the
piece of
universe
paper, and that's your
for
journey.
this amount of extra detections
And
to be
then
then
entropy.
discovered here on planet Earth. Or in other words, we would just require way, way more dark matter everywhere. And that doesn't exactly match
Well,
with
the beauty on that, you put it back.
the original prediction. And so a potentially different explanation was required to explain these 53
And
extra
in that
detections,
simple bit of
which is
beautiful,
what the scientists
I
have
don't
been
know, did I
trying to
post
do
the
for
one
the
with the
past
cop
year and a
out
half
there?
now.
Yeah.
They've been
Well,
trying to figure
there you
out
go.
what
That's
exactly
what I'm
can
talking
be
about.
used to explain. And so the scientists
Officer,
behind the
come
paper
around,
you
know
can
your
find in the
feeds and
description
speeds.
below
This,
constructed an entirely
nope.
new model in order to try to explain the observations, and their physical model
I have a
seems
knife
to
somewhere around
fit
here made out
almost
of wood.
perfectly. But strangely enough, their model does not focus on dark matter at all. It focuses on that other, even less understood concept, dark energy. Alright, so what exactly is that? Well, it's that other concept we know so
Good,
little
but
about.
you're gonna have to play it like
I
you play
think in the
this.
past I've
Okay.
probably made about 3 to maybe 4 videos
Maybe.
in the last few years, and that's how little we know about dark energy. It's that stuff that we believe
See
exists
how it's
everywhere
muddy
in the
and
universe,
the grass needs to be
and it's
cut?
that
Yeah,
stuff
that's
that
mud.
seems to encourage and increase the acceleration of the expansion of the universe, but we don't really understand what's causing it and how exactly any of this works. We only know about
Yeah.
this mathematically. It seems to represent approximately
It's short. It
68%
shouldn't
of
be.
everything
When they're
in the
hard,
universe,
you have to
with
really look at what
approximately
you got there.
27% being
You know, it
the
should be.
mysterious dark matter,
He,
and everything else being the stuff we're
So
familiar
my
with, the
safety
things
lady
we're made
changed
of.
over from
But whatever
Johnson and
dark energy
Rhodes where
is,
they got a new one,
it does seem
and
to
it
be
was
an actual
something
phenomenon as
downtown.
well. It
Safety
seems to
lady
somehow
over there at
accelerate
Johnson and
the
Rhodes.
expansion of the universe,
From
something that has been proven
Doreen,
over and over
and
again
then
using
without
different
any of that.
experiments. There's actually at least one
You gotta-
major experiment trying to figure this out, known as the
seatbelt on
Dark
the road,
Energy
you
Survey.
gotta
Ironically
do
though,
that,
instead of
and it's right there
discovering
in
more
East
about dark
Branch,
energy, in the past this experiment
you got
has
Dow.
allowed us to discover some of the least visible objects in our own
And
solar
flamograph
system,
calculator.
and also in the vicinity in our own galaxy. We still haven't really learned much about dark energy itself from this particular experiment. And generally, the way that these experiments work is by trying to look really far away into outer space in order to measure the actual speed of the expansion of the universe. And by doing this, we're hoping to understand what exactly is causing this and what exactly is going on. But in terms of the actual explanations for, I guess, a potential particle or whatever else is causing all of this, there are just not a lot of explanations. For example, in most astrophysics textbooks, or I guess even most sciences today, will actually say that it's just part of the equation, it's just part of mathematics. Nothing is causing this except for the universe itself. But this particular explanation does not really satisfy everyone. As a matter of fact, one of the biggest and to some extent most well accepted explanations, something you can read about in some of the papers in the description below, is this unusual particle that the scientists refer to as the chameleon particle. And it's called chameleon because of its ability to sort of blend in to various types of environments. Or to be more exact, they're sort of able to change their mass and even probably other properties based on the amount of mass present around them, based on the total density. And so if they're located inside a high-density area, such as, for example, inside some sort of planet, even though their mass is going to become really large, they're not going to be producing a lot of force. They're only going to be pulling things apart at a really small radius of about 1 millimeter. Yet, if these particles reach low-density areas, so basically somewhere in between galaxies, somewhere in between galactic clusters, their mass will suddenly decrease dramatically, but at the same time they suddenly acquire an ability to influence objects really far away, which basically means that they change depending on the location where you find them. And so to try to explain this, the scientists once again focus on the sun. But in this case, a specific area of the sun known as the tachocline. Tachocline refers to the area you see right here in the illustration, and it's a kind of a transition area between the radiative zone and the convective zone where a lot of things mix in the star. This particular region is usually present in most stars that are more massive than about 1.3 masses of the sun,
Who knows if he's doing it for money or if he's doing it for
and this particular layer is formed because these two zones have slightly different properties. The internal radiative zone sort of spins as a kind of a solid body. This is mostly due to the amount of pressure present inside the star, but the outer region moves more like a fluid. And because of this, there is a kind of a friction or a kind of a shear created between these layers, which the scientists believe is also responsible for creating tremendously powerful magnetic fields in the sun itself. And so tachocline is very likely an extremely magnetically charged area with a lot of other extreme effects as well. And so in this case, the scientists wanted to see, so what would happen if a hypothetical chameleon particle passed through this particular region and interacted with the extremely powerful magnetic fields present in the tachocline of our sun? And it looks like, according to the scientists, mathematically it's definitely possible. It looks like if a dark energy particle was present in this highly magnetic area and then essentially interacted with the powerful magnetic field present in the tachocline, it would sort of get coupled with the dark energy particle, with the chameleon particle, and would produce what the scientists refer to as the dark energy quanta, which would then travel toward planet Earth and would then interact with xenon, producing the observations with the exact properties detected in the Xenon 1T experiment. Or in other words, they believe that the dark energy particles inside the sun very likely were responsible for the 53 extra detections that we've discussed last year. Now, this by itself right now is a really exciting study and also a really exciting proposition. Mostly because it suggests that we can use these unusual xenon-based detectors to not just look for potential dark matter, but to also look for dark energy, or at least one particle possibly responsible for the effects of dark energy. Although that's of course assuming that those original...
Alright, fine, 42.
detections from 2016 to 2018 were not a fluke.
No,
for all we know, it could still be explained using something entirely different, possibly even some sort of interaction we never really considered. So, for now, we don't really know what exactly was discovered, but as of today, the mathematical model explaining dark energy as opposed to the axions that represent dark matter seems to make a little bit more sense. And that's why this is probably going to be a study we're going to come back to and talk about more in some of the future videos. And that's mostly because from all of the experiments in the past and from all of the different discoveries, we've never really gotten that close to potentially discovering the origin of dark energy. And so for now, that's sort of all we know. There's a slight chance we might have found dark energy, but we're not going to know for sure for possibly a few more years. On that note, check out all of the relevant links in the description below, subscribe if you still haven't, share this with someone who wants to learn about space and sciences, and maybe come back tomorrow to learn something else. Maybe support this channel on Patreon by joining the channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye-bye.
I think it's Infinity of the Mind talk about it, but I'm not sure if that's who did it or not. There was another one. No, they're all wrong. You go out there with a camera and you do the process like it's making Granny's apple pie, right? So you hit that Granny's apple pie number and people like your Granny apple pie, they be responsible and do on Patreon for $5, I guess. That's a whole bunch of them. Times that many and they hitting them. Give me the money button. Sure. Oh yeah. Put out some content. What do they want? They want astrophysics from Anton, and that's what calculus says, because otherwise it's not astrophysics, not